Hello everyone, this is Ali Hantal. I serve as a Technology Advisory Committee member for Ankara Metropolitan Municipality, and I'm the founder of XR Masters, an XR agency that specializes in creating spatial web solutions. Today, I'll be talking about the new spatial web era that has just started and provide information about the Digital Twin City project that teams from Ankara City and XR Masters are currently working on. Then I will invite my friend Jan-Erik Vinje for our panel discussion. He is the co-founder of OnSite Viewer, and he's also the managing director for Open AR Cloud Association. We will talk about new and fascinating technologies and their effects on smart city initiatives. Let me start with defining what is spatial web or AR cloud. AR cloud or spatial web encompasses the creation, management, and use of persistent, dynamic, and shareable 3D representations of physical spaces and real-time services to offer AR experiences to users. What is different with AR cloud compared to conventional AR? Conventional AR generally requires a target image, a marker, or if there are no markers, requires the user to tap on the screen to place an AR object onto a surface after the device recognizes the surface. The first video that you're seeing is actually showing how a device is recognizing a surface. You'll see that there will be a shaded area, there will be dots, and that means exactly right now that the surface has been recognized, and then when tapping on the screen, you'll see that the AR object, in this case, AR room that you can walk into, is placed. There's also another example here on the left side, and that is my business card. It's been like 3.5 years, and you can see that my business card becomes alive on screen, and there are some AR content being superimposed on the card, including my digital twin of myself, which was actually scanned, captured volumetrically. The third video that I would like to show you is about a marker-based AR navigation example. You can see that this was actually for a high school campus. You can see that once the marker is being read by the camera, you can see arrows on your real world superimposed onto the real world for instructions on where to go next. There's also a GPS-based AR solution. However, GPS is unfortunately not the right technology. Think about sharing your location using a WhatsApp app. There's always a minimum 10 to 20 meters, if not more, depending on the weather, of error about your exact location when sharing location via GPS. That's why conventional AR is not the right way to go. So the question is then, can AR cloud-based AR achieve this? And fortunately, the answer is yes. Let's try to show this. What would this mean for us with an example? I like this image a lot. It was published on Harvard Business Review's Spatial Edition in 2017. Think about your driving directions on your mobile phone. As you very well know, this is an experience where physical and digital worlds are separated. This solution creates a cognitive load for the user, as mentally transposing GPS images onto the road ahead is demanding and prone to errors. However, if you look at the image on the right, digital data is superimposed onto the real world. As I explained before, this is not possible with conventional AR solutions, and AR cloud-based AR is required for superimposing accurate and persistent digital data onto the real world. So then, AR cloud-based AR does not require markers or does not require the user to tap to place the digital content. AR Cloud is capable of providing shared and persistent AR experiences, 10 to 50 centimeter accuracy, as opposed to the tens of meters in GPS, which can be city or country scale. It could be large scale. For instance, here is a stadium AR experience. Here, Dallas Cowboys and AT&T demonstrated a stadium AR solution where the fans were able to visualize the digital content using their Android or iPhone mobile devices. So it's cross-platform. They were able to see real-time data and information at the same place at the same time. So it was shared, persistent, and at a large area. Before moving on with more interesting examples, let's discuss how persistent AR is achieved. The main difference is that for this new technology to work, the digital twin of the surrounding has to be created and placed on top of the real world. And to be able to create it, the surrounding must be captured using a scanning or capturing device. The good news is that this could be a mobile app that runs on an Android or iPhone. Check this video out. The mobile app is telling the user that is scanning the area where to step next. So the next point has been showed as this place. And once that is done, the person starts scanning the environment. Oops. Yes. So once that's done, now what happens next is a point cloud of the environment is created, and a point cloud of Amsterdam Dam Square is being showed on this video. You can see those 3D point clouds. The next example would be the point cloud of Taksim Square. So once the digital twin of the surrounding is created, the next step will be to create the 3D content and place it on to the real world. Last step will be to visualize it. This next slide that you're viewing is the 3-step process for the new spatial web or AR cloud experience. The next video shows Snapchat's City Painter app that was demonstrated in October of last year. For this experience, Snapchat's team scanned about 15-20 blocks in London. And as you can see here, the digital twin point cloud of the city was placed exactly right now on top of the real world. Then the users started painting the walls of the city. And as one paints a wall, all others were also able to visualize the experience, and they were also able to participate and paint the walls as well. This was an amazing experience. Another example is the AR aquarium experience we have created. We have placed over 30 pieces of 3D and animated content on Taksim Square. This is actually the point cloud of Taksim Square that is being used for the technology to work. But now you will be able to see how we have actually done an occlusion. See, the AR object is going behind the Marmara Hotel. And this is a very good example of how shared experience that was. And here is a clownfish, Aquaman. So this experience is shared among users. And if one user interacts with an object and there's an animation or a content activated because of that interaction, all other users are able to see that and visualize that. So this is a multi-user shared and a large scale AR experience. I would like to show you, actually this video has been created by Keiichi Matsuda 4 years ago. At the time, it was not possible to do this with the technology. However, currently this is a very easy technology, very easy solution to achieve. As you can see, proximity-based ad just showed up, coconuts, when the user got a certain distance away. And the user is seeing all around with different instructions, and now he's going to pick up a product to just visualize the ingredients and information about the product. I would like to also show you this experience, and you will see that this experience is another futuristic experience, again by Matsuda. You can see that there is information. Now, all of this points of interest and all of that is being given. So this was very helpful. It cleared the road before the bikes are coming, so there were sensors apparently. However, I think you will agree with me that this was an overwhelming experience. The information being presented is too much. However, it does not have to be this way. This will bring us to the next slide. And this next slide was presented during the Leap conference by Magic Leap in 2019. In this new type of web, there will be no web URLs, websites, addresses, but there will be layers. As shown here, there can be entertainment, mobility, digital world, communications, physical world. On top of physical world can be emergency layers or many more infrastructure layers. So the new world would be a spatial web. Instead of World Wide Web alone, it would be spatial web where we will pick the right layer, unlike the bus experience, the right layer whenever we want it and wherever we want it. I tried to quickly go over this exciting and new technology. As we're about to take a giant leap forward in the way we use the internet and the AR cloud, how we interact with each other, how we train our teams or educate our kids, how we do business, or how we run cities, how we run smart cities will change dramatically in the coming 5 years to decade. Yes, how we run smart cities will change dramatically. And this brings us to the Ankara Digital Twin City project. I am thrilled to announce that we have been working with Ankara Metropolitan Municipality on a pilot project. We're currently planning the first phase where we focus on creating the digital twin of Ulus Siye Kızılay Tuneli Hilmi touristic path, where we'll be with an app, the tourists or users would be downloading an app, and the app would support both 2D map features and augmented reality. there will be 20 points of interests along this 4.5-kilometer path. And we will provide detailed on-site information about the point of interests with 2D photos and videos and texts and 3D models. And there will be AR navigation. Right on the left, you're seeing this actually images from Bari, and that is actually be almost the same way where, like the one slide that I showed you earlier, there will be on real world, there will be arrows and directions for the users to go to one of these 20 point of interests. And during the future phases, we will add more points of interests. There will be a module for remote content management. So anyone from the internet will be able to log into a website and will be able to place 3D content on the city. There will also be user-generated content placement. So users will be able to generate and place content. Then we'll add business listings, which will bring now revenues with spatial ad management, augmented reality ad management. Then we'll have shared and multi-user AR games. Then the next phase that we are planning to do is cover the entire city so that whole entire city actually become a digital twin of the city can be created. And the next thing you know is this could be a test bed for an open spatial computing platform that we will learn more about from my friend Jan-Erik Vinje. As I explained, we will soon be inviting the co-founder of On-Site Viewer. But before doing that and asking him questions about how Ankara can be a test bed, one of the test beds of this new technology, I would like to ask you to go for a Q&A session, and let's see if you have any questions. I would be glad to answer them.